So let's go ahead and try this example. If you recall, just the derivative of y with respect to x of a quotient rule is going to equal to the derivative of the top, where u is the numerator, times the bottom minus the top, times the derivative of the bottom over the bottom squared. So that was kind of our little recipe that we just developed. So why don't you go ahead and try this, hit pause on the video, and then we'll go ahead and see, I'll work through the problem and see if you're able to get it. So pause the video. Okay, so applying this, remember this is my u. I'm going to kind of highlight that here and see that we can make sure that this is u. So that's going to be this guy right here. This is v, so that's going to be v's 3. And where did this come from? We derived it in the first lecture. So what it's going to say is dy dx is going to be equal to the derivative of u, or the derivative of the top, times the bottom minus the top, which is again u. I should be calling it the numerator, but we always say top and bottom kind of in this fashion. Derivative of the bottom all over v squared, or 3x minus 2 squared. Now sometimes we'll run into simplification, and this is now algebra. There's no more calculus involved here. Many times we want to cancel the 3x minus 2, but there's not a 3x minus 2 in the second term. So there are three terms. This has a 3x minus 2, this has a 3x minus 2, but the second term in the numerator does not. So you cannot cancel. Now you just apply some algebra, distribute the 2, distribute the negative and the 3, and you get negative 6x minus 3 all over 3x minus 2. And rarely do we multiply that out. We just leave it as 3x minus 2. It's easier to deal with instead of squaring it when I start to look at other things. So my 6's cancel. So I think I've got 4 and negative 3. Negative 4 is negative 7 over 3x minus 2 squared. Now if we think about if this derivative is going to be positive, negative, I claim this thing will always be positive. So that means the slope at an instant for this graph will always be positive. If I square something, that's always positive. And this negative 7 doesn't have a variable, so it's always negative. So again, if we try to look at the sketch of that graph and just verify this, from the denominator at 2/3, I have a vertical asymptote. From thinking limit as x gets large, I'm going to have 2/3, y equals 2/3. And I believe it's going to go like that. The slope of that's always negative, and the slope of this side is always negative. They're always decreasing. And we can verify that and check. It looks like numbers over on this side, their slope's almost 0, but not quite. Now let's pick x to be 5. So if I plug it into my derivative equation, 15, because 3 times 5 is 15, minus 2 is 13 squared. Would you agree that that is a very small negative value? So it looks like it's working. We can do the same thing over here. I can plug in negative 5. Plugging it in, it looks like I get negative 17. So negative 7 over negative 17 squared. So all I did was, in place of this x, plug in an input. So yeah, it looks like it's very small negative value. So that's the first example. Let's try one more. So why don't you pause the video, work this out, and then play the video to check yourself. Make sure that you did the algebra correctly using the same formula. All right, applying what we proved earlier, dy dx is, again, the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So making note that this is my u, this is my v. They are both functions of x, my dy dx. And I kind of get that little saying going, the derivative of the top. I say it and I write it down. Derivative of the top times the bottom minus the top times the derivative of the bottom. So the derivative of the bottom, if you recall, we power down. That's when the exponent comes down, and then I decrease that power by 1 all over x minus 2 squared. Let's use some algebra on this. I have 3 terms before I start simplifying here. It looks like they all have an x minus 2, at least 1. So this one I'm going to cancel. There'll be 1 left, and there'll be 1 left. So now what I'm going to do, and don't think those are x's, I've just gotten rid of those powers there. So dy dx, I'm going to distribute the 2. I'm going to distribute, in this case, the negative 2. And then I'm left with x minus 2 squared. So we don't want to multiply that out. So if I'm simplifying this, I'm left with negative 2x's on top. And it looks like a positive 4. And the denominator is x minus 2 squared. So we can graph that and verify as well. So tomorrow, you'll be working on homework of just practicing taking these derivatives. You want to make sure that this formula here is something you have memorized and you know how to prove.